Hello, my name is Joshua Jaworski, and today I will give you an overview of the role of the blockchain technology on peer-to-peer residential energy markets. So as an introduction, where does blockchain and the smart energy market match together? So blockchain is a distributed ledger technology that enables users in a network to perform transactions without necessarily knowing each other. This is in a secure manner. And increasingly, the future of energy, of the grid, is becoming more distributed now with the uptake of microgrids, electric vehicles, batteries, and photovoltaic arrays. So I'm going to explain three important components of this project, which is the market design, the user behavior, and the role of the smart contract. So to start, the energy market design is very similar to what we see in the wholesale centralized energy market, which is just a clearing algorithm that matches the highest bidders with the lowest sellers into finding an equilibrium point past which no transactions are executed. So how do we keep the market dynamic? So we know that users have the option to ask from the utilities for different pricing. Like, for example, here we have the tow prices, which are time of use prices. So we have peak prices, let's say between 8 a.m. and 10 p.m. and off-peak prices, let's say between 10 p.m. and 8 a.m. So early in the morning. The idea is for the utilities, for users to shift their loads to times where the grid is less congested. We also have flat rates, which is just the same rate paid for electricity, no matter the time of day. The feed-in tariffs are rates offered by the government or utilities to help users that install photovoltaic panels to sell their excess and recover their investment. So with users with such a variety of prices and access to local generation, or users that don't have local generation but want to buy from their neighbors cheaper energy, gives the dynamism that we need for this market to be successful. So talking about the users. So in this demonstration, we are going to consider users with solar panels and battery storage. Normally, the smart contract would handle the data directly coming from the instruments, but for purposes of this demonstration, we simulated realistic demand profiles as seen on the top graph and realistic solar just production factors as seen on the bottom graph for 7 days. So what does the smart contract actually handle? So the smart contract is a state machine. So it keeps the state of all user preferences. It takes the data from the instruments and it takes the current time period and uses all this information to perform a predefined market clearing function. So essentially the contract is called every hour to do a market clearing function with any data it currently contains. So all these inputs are then used to provide user registration, market clearing, balance transfer, and also updates to user preferences. So this is just a simulation of one of the possible cases for load shifting with batteries. So when the P2P market is in place, we can see how the blue curve, which is the regional consumption for a 20-house residential community, is reduced due to the batteries transferring power essentially from the valleys, from the peaks to the valleys. So we can see a smoother profile. We can see probably a lot of users saving money on these high peak prices by buying energy from battery users. So before the actual front user interface demo, I'm going to give a small tour to the backend. So this is the Solidity code of the smart contract. So as mentioned, this is essentially a state machine that keeps the information that is given to it. So here we can see how it stores just all the information related to batteries, solar capacity, to energy access, to its bits preferences in the smart contract. It handles also register function. It allows the users to update their bits, so their selling or buying prices. And then inside the hood is just everything that's needed to handle just the market clearing. So in here we can see, for example, just how balance transfers are done, like battery charges, covering the demand for other users. And at the end, all the energy that is not met by the market is going to be met by the grid. also have a linking code, which is done through Web3.js. So this code just links the front end and the other parts of the backend of the application to the blockchain part of the smart contract application. So you can see this, for example, this register function is linked to the pressing of a button here in the front end. So now to the demonstration front end. So as we can see, this front end is linked already to a MetaMask client. So I can just have a couple of test accounts here. So I can just choose account 3. And if I want to register for the platform with a flat rate, I do not have a battery storage system installed. Let's say that my storage capacity is just 4 kilowatts. I will register, and then it will automatically open my MetaMask account, asking me to pay for the gas fees. That's one thing to mention, that we are only using the network for gas fees payment, and the balances are kept by an internal token of the application. When we confirm this transaction, you can see now our current settings. So the settings for the user using the wallet. Here are the 4 kilowatts that I just registered. I don't have any batteries. This is my current balance, which is an internal token currency. I can then just set my bits. Since I'm a solar producer, I probably just like wanna sell some energy, maybe below the time of use peak rate and above the solar fit tariff for sure. Set this to 0. And then I can set my prices, and again, I can use the network to pay for my gas fees. And yeah, just as a second demonstration, I can just choose a different account. Let's say account 4. It's not connected. There we go. Now I can select a different tariff. I have my battery system installed, and I don't really have. So we'll go through the same process of paying for the gas fees. I'm a battery owner, so I probably want to buy cheap electricity. So let's say I want to buy below the flat rate price. So yeah, let's just say I buy cheap electricity here. Here it's just like off peak. Now I can see my current settings, my toll rate, my bits, my balances, as you can see. So right now we have this button to clear the market just for demonstration purposes, but in the real application, the function of clearing the market will be done by a timer. So every hour or every 15 minutes, whatever the trading period is established, we'll call the smart contract to perform the market clearing. So if I just clear the market, essentially, this is the gas fee paid by the application owner or the contract owner for this. So here it says like a successful market clear message. So if we just go see the current settings, we can see that our balance changed because we're at off-peak period. There's no solar energy. We can only buy from the grid. So now we have to pay the grid to satisfy our charges. We can also see that the battery got charged. This is in watt hours. Because it is preferred to, this is a toll user, so he would prefer to charge its battery when we have this really low energy price, and then discharge it when it's peak price. So yeah, that was just a quick overview of the front-end interface, how it works, how it seamlessly interfaces with your MetaMask client, and you can also interface with other wallets. We keep developing this app and keep you posted. Thank you very much for watching.